the Pearson Edexcel IGCSE specimen sample paper of the further pure maths. This is paper 1. So yeah, it's calculator, nothing much more to say. Got 2 hours to do it, let's get straight into it. The first question is just drawing some lines, which is fun. Obviously rearrange these to be y equals mx plus c. Oh, sorry, wrong way. Y equals mx plus c, so divide by 3, move the 2x over, you get this. And this one here, just divide everything by 2, you get that. So this one has a y-intercept of 8/3 and a negative gradient, so it looks a bit like this. 8/3 negative gradient. We can work out this point if we want to by putting y is 0 in. On the x-axis you're not going up or down, so y is just 0. So if you put in y is 0 into here, you can get x is 4 out of that if you do some maths, which I can't bother to do. And then this one, obviously, y-intercept of a half, gradient 2, so it's going this direction. Looks a bit like this, I guess. You can again work out by putting x as 0, sorry, by putting y as 0 in, you can work out x minus a quarter there. And yeah, that's the first question. Show here by shading a sketch region R defined by this. So we want to be underneath, so y less than means we need to be underneath this line. Needs to be also underneath this one. We need to be above the x-axis. Y is 0 is above the x-axis. And we need to be to the left of x is equal to 2. Now x is equal to 2 is somewhere here. I do probably want to know whether it's to the left or the right at this point. So I just actually worked out what this point was by setting this equal to that. Times everything by 3 and times everything by 2. So in effect, times everything by 6, you get this, and then you can of course solve. Now this value is less than 1, so x is equal to 2 is to the right of this point, so it's over here somewhere. So this is the region that I'm looking for here. I think this was probably unnecessary, but I'm not 100% sure. So I did it anyway. Always better to be safe than sorry, particularly with question 1. You know you can do this, you know you can get it right. You may as well do it just for the mark, you got plenty of time. Now this question here, it doesn't actually tell us whether we're working with radians or with degrees, but since they give you pi as your arc length here, seems natural to work in radians. The arc length in radians is given by r theta. It's also, let's face it, just easier to work in radians, and you probably also want to do the practice, so yeah, let's do that. Arc length is r theta, r is 6, arc length is pi, so that means theta is pi over 6, otherwise known as 30 degrees, in case you want to kind of think about it like that in your head. Now if that's pi over 6, this whole angle is of course pi, or 180, which means this angle is pi minus pi over 6, which is 5 pi over 6, which means I can work out the length of AB by doing some cosine rule with AB squared equals 10 squared plus 6 squared minus 2 times 10 times 6 times cos of 5 pi over 6. Now of course this can just go straight into a calculator if you want to, even with just a square root over the entire thing, so you just have to type it in once, the whole thing. Otherwise you can do it a bit more slowly if you want to. Cos of 5 pi over 6 is minus 3 over 2. Think about the cos graph, it goes negative at this point. Doesn't really matter though. Again, you have a calculator, so you may as well have not bothered with this working, just put it straight in. Anyway, the area of the shape ABC is going to be this sector plus this triangle. So start with the sector. Again, in radians, the area of the sector is just r squared theta over 2. R is 6, theta we've worked out is pi over 6, that makes 6 squared times pi over 12. I've put this divide by 6 down on the bottom here, which is 36, divided by 12 is 3 pi. And here we have a triangle is a half AB sine C, with the A and the B being the sides meeting at the angle C. C is 5 pi over 6. Sine of 5 pi over 6 is the same as sine of pi over 6, again thinking about the symmetry of the sine graph. So that's just going to be equal to a half. A half times 10 is 5, 6 times a half is 3, put them together and you get 15. And so it doesn't say how to leave the answer, but since I'm a pure mathematician, I'm going to leave it as 15 plus 3 pi. If you left it as whatever decimal that equals, then great. Question number 3, quite a nice question here. Anyone doing A-level maths, I know you guys may be usually a bit too young for A-level maths, but this is a very classic A-level maths question. A-level mathematicians should be practicing on it, I think. Tan is defined to be sine over cos. I might just make a small remark here that this is fine as long as cos of 2 pi plus 30 is not equal to 0, because then I would be dividing by 0 and I don't want to do that. Essentially I'm just saying that I don't want tan to be 90 if we're working in degrees again. Or 270 of course. Anyway, now I'm going to times everything by cos of this thing, because that will get rid of this obviously. 0 times that is still 0, and that makes a square here. If I replace this cos squared with 1 minus sine squared, I can then get a quadratic in sine. And I'll write that quadratic with the sine squared as being a positive thing, just because. Okay, so that's all just simplifying there. At this point, you kind of hope that it factorizes. I wrote off to the side y squared minus 2y squared minus y minus 2 equals 0, and tried to factorize it just because it's easier to see like that, but it didn't. So you just get out the quadratic formula, you put it all in, and you end up with these two numbers here. Again, this is a calculator paper, so not too difficult to just put these in the quadratic formula. Maybe something to say here is that this is a quadratic in sine of 2 theta plus 30. So when you use the quadratic formula, when I say that, what I mean is sine of 2 theta plus 30 is this thing squaring here and the thing on its own here. So when you use the quadratic formula, that's what is equal to here. It's not always x equals. It's whatever is being squared here and whatever just to the power 1 here. Because it's a quadratic in this thing, in that is kind of what that means. Anyway, hopefully, yeah, I don't know. Anyway, so these are the two answers that you get. Of course, sine of anything can't be 1.28. Sine and cos both max out at 1 and minus 1, so that's not a thing. But this, if we sine inverse, we get this. Now, the problem with this is, this was our original bound. Now, we're searching for 2 theta plus 30, not theta, so times this by 2 and add 30, and you get, that should be a 390, apologies. Here you can see I've times by 2, which is still 0 plus 30. This should be times 2 plus 30, which is 390. It's not going to make a difference, but that should definitely say 390. Anyway, that's not in the range, so just quickly draw the sine graph. What this is saying is sine equals minus 0.78, which is down here somewhere, at minus 51, fine, but we don't care because it's not in the range. The next time it happens is 51 degrees further than 180. Just by the symmetry, again, of the graph. So 51 further than 180 is 231. And then here, 51 back from 360 is what I did to get 308. And then, of course, take away, those are all in the range. We've stopped because we've maxed out the range, 390. Again, this should say 390, but you can see there's no more solution up to 390 either, so that's fine. This doesn't matter. Take away 30 and divide by 2, and you get your two solutions. Yeah, very classic A-level question, so well done if you're already getting that right. Particle P is moving along the x-axis. The velocity is given by this. When something is at rest, that means its velocity is 0, so just put a 0 into here and then solve it. It does factorize if you look at it carefully enough, and you get those 2 times, which is fine. So those are the 2 values. When time is 0, the displacement is this. Find the displacement. Now this is when you do enough of these questions, you know that this here essentially means that you're going to have to integrate. When they give you some values like this, it just means the next thing you're going to have to do is integrate. Of course, you probably hopefully know that because you should know that if you integrate velocity, you get displacement. I think of it as like a ladder of displacement, velocity, acceleration. Going down the ladder is differentiation, going up is integration. So displacement, velocity, acceleration. To get from velocity to displacement, you go up the ladder. I realized there wasn't a ladder there. I was picturing it in my mind. Hopefully you were too. So we integrate this. So we integrate the velocity. That's not too hard to do, but remember the plus c. And this is what I'm saying is this here, massive Chekhov's gun for the fact that you're about to have to do some integration. Because to find the value of c, we put in these two values. We put in when t is 0, s is minus 4. Now, of course, this is a bit like a y-intercept. If t is 0, all this goes away, and that just makes c minus 4 as well. And so this is our formula for this displacement in terms of t. Finds the displacement when t is 6, so just put t is 6 into there, type it all into a calculator, and you get 14. At time t seconds, the acceleration is a. So thinking about that ladder again, to get the acceleration from velocity, you differentiate it. So let's differentiate this velocity here. That makes that. When a is 0, so just put a is 0 in, solve this, and you get t is 19 over 8. Good. Question number 5. Two numbers such that the sum of the squares of 2x and y is s. So that means 2x all squared plus y squared equals s squared. Square this like a normal person, not like an idiot. So it's 4x all squared. Sorry, it's 4x squared. So this is just a similar equation, right? We've got this and we got this. Now, their equation for s doesn't have a y in it. So my idea will be to get rid of y here. Take this equation, rearrange it for y, and then square it all. Remember to square sides separately, not terms. Square the whole side here. Expand out the bracket, and then put that expression in for this y squared, and tidy up, and you get what they wanted. Using calculus, find the value for which s is a minimum. Whenever you see minimum, maximum, you're just differentiating. So let's do ds by dx to get this, and let's set that to be 0, and we find that x is 52 over 16, which is 3.25. Now, to justify that this is a minimum, you could differentiate again. In fact, that's what I did because differentiating this is so easy. And if it's bigger than 0 at this value, then it's a minimum. Now, of course, this is bigger than 0 for any value, not just this value, because this value has nothing to do with it. It's just the number 16. So any stationary point is a minimum that you would have found. And of course, that would be the other way to justify this, is that we'll look at the thing that you're dealing with. That's a quadratic. We all know what that looks like. It's a U shape. It has a minimum. This thing is positive, so it's a minimum, not a maximum. You could have just written that. But anyway, that's what I did. Find the minimum value of s. That's when you take this equation for s and put this value for x, because remember, this is when the minimum happens. So you put that into the equation here. You just type it into a calculator and you get your answer. 6, again, another really interesting question that leads, it's done a little bit of A-level, at A-level, but it also leads to some really interesting things about solving equations that look like this, which is something you might do in year 13 maths. So anyway, we want to differentiate, we want to find dy by dx. Now this is a product, it's this thing times this thing. So I'm going to do some product rule. Product rule says to differentiate the first thing, now the differential of e to the x is just e to the x, and then leave this one alone. So actually, it looks like I've just left the whole thing alone because this differentiates to itself, but I've differentiated this one, left this one alone. Then I add on, leaving this one alone this time, and then differentiate this one to make 2x minus 3. So that's product rule. Differentiate, leave alone, differentiate. Now I need to do that again. I need to find d2y by dx squared. So I'm going to do that twice now. I'm going to do it on this thing now. Now actually we've already differentiated this though, right? Because it's the same as y itself. So we've actually already differentiated that. So this just differentiates to this. And then this thing, again, differentiate this one, leave this thing alone. Leave this one alone, which is an e to the x. Differentiate that for a 2. So that's my d2y by dx squared. And now here, what I'm going to say is left-hand side, which is this thing, the left-hand side equals, now y is equal to this, so I'll put this in for y, minus 2 lots of, so in brackets, dy by dx, which is all of this, that's all of that, plus d2y by dx squared, which is all of this, which is on the second line here. Now if you look carefully, after you've expanded this bracket here to make a minus 2 lots of this and minus 2 lots of that, this, and this all cancel. There's plus 2 of them and minus 2 of them there, so they all cancel there. And likewise, this, and this all cancel. And you just end up with 2e to the x, which is equal to the right-hand side. So 8 marks for that, which is really nice. Yeah, the idea behind this leads towards solving equations that look like this, which is a lot of fun that you might have in year 13 and at university as well. Cool. So this is one of those times where you roll your eyes whenever a teacher says, make sure you read every question in the exam. Make sure you read every question in the exam, because you get 2 marks here for typing these things into a calculator. 2 marks, 2 whole marks. I guess you also have to know how to round as well, which is tricky. And then you get another 2 marks for plotting these points on a grid. Oh my god. And drawing a curve through them, I guess, which I've actually done a terrible job of, so maybe I only got 1 mark at it. Anyway, then you get 4 marks for actually doing something interesting, so that's good. You don't want to solve this equation, essentially. You want to use this graph somehow. So this graph has this thing drawn on it. So I want to get this thing out of this. So okay, let's add x to both sides, and I'm also going to drop the 2 down to here. And now let's divide by 2. Now the reason I'm doing this is because I don't want to see any logs. I want to see powers. So I kind of isolated the log. That was my idea here. I isolated this log. I wanted to get rid of the square because that just feels very natural to do. But I want to isolate the log, so now I can do 2 to the power of both sides. Now as soon as I got to this line though, I was very happy that I was doing the right thing, because this of course here equals this. So it's already shaping up, right? So now 2 to the power of both sides gives you this. And now this is basically this. I just need to add 1 to both sides. And now this is now exactly this thing here, which is great, because I've got this thing equal to this thing. Think backwards here. If you were asked to look for the intersection of y equals 4x minus 5 and this, or solve this and this, you would set them equal to each other, which is just this line. So we're just kind of working backwards. But in any case, what we need to do is draw this line here. When x is 1, you get y as minus 1. When x is 2, you get y as 3. Draw the line. And this intersection looks like it's about 2.8. 2.7, 2.8 is what it looks like to me. And yeah, that would be the answer. Really nice question. Question number 8. The sum of the series of mathematical sequences is given this. I was really confused by this because in my head I expanded this out and got n squared plus n, and I'm like, that's a quadratic sequence. What are you talking about? It's not arithmetic. Read it again. The sum is given by this. This isn't the nth term of the sequence itself. It's the term of the sum. So find the first term of the sequence. Well, if you just add together all the terms that are just the first term, you'll just get the first term. So s of 1, which is 2 times 4, is just equal to the first term, because the sum of every term but just the first one is just going to be the first one, right? So yeah, the first term is just going to be 8. The common difference, well, if I find the sum of two terms, by putting 2 into here, 2 times 2 is 4, times 5 is 20. The sum of two terms is 20, the first two terms. I know the first term is 8, which means the second term must have been 12, which means the difference from 4 to 8 must have been 4. So that was my logic. The nth term of the sequence is this. Now I can work out the nth term, right? Because I know the jump is 4, so it's 4n. And the first term is 8, so I just need to add 4 to it. So the nth term is 4n plus 4. Just verify this works for n is 1 and n is 2. That gives you 8 and 12. Good, it does. So that's t to the n, or tn. So tn plus 3, this is just, it's a bit like functions in regular GCSE maths. Just replace the n with an n plus 3. Just replace the n with an n plus 3, and that's tn plus 3. Likewise for here, replace the sn with an n minus 4. So replace this with an n minus 4, replace that with an n minus 4. Tidy that up if you want to. And now 6 lots of this equals 7 lots of this. And you just very slowly need to solve this. I'm not going to spend too much time on this because I'm sure we all know how to solve equations. This is just what my working looked like. And here, this is kind of interesting though. You could just get out your calculator and do the quadratic formula or whatever, but I always at least am searching for interesting ways of doing maths. The thing is, nth term, that's a positive integer. You can't have a negative term, you can't have a half term. This has got to be a positive integer. So you could use the formula, yeah, but you know that at least one of these answers is a nice positive integer, which means it must factorize. Now, if you're making 3n squared, you must use a 3n and an n, so that's cool. Now, this bracket is not going to be the one that's going to be the answer, because this bracket is going to give you something over 3, and that something isn't going to be divisible by 3, otherwise this whole thing would be divisible by 3, because you could just factorize the 3 out of this bracket. So this is going to be the thing that leads to your actual answer. Now, if it was n plus something, that would give you n is a negative answer, which you can't have. So this must be n minus, and this must be a plus. So, you know, it's tempting to say, oh, this is annoying to factorize, but I've managed to logically deduce all of this. And that's quite a good way of going it. You know, I got pretty far here. Now I just need to try stuff. 16, the first thing I tried was 8 and 2, and it just works. And so the answer is n equals 8, which you can verify if you want to by trying it out. But anyway, yeah, just a cool bit of actual maths there. I'm always on calculator papers. Long-time viewers of the channel know that I hate calculator papers. I'm always trying at least to be kind of intelligent about what I'm doing, rather than just grabbing a calculator at the first opportunity. Because for those of you who are young and watching, when you go to university to do maths, you will not get a calculator outside of the stats papers. So if you don't enjoy doing fun maths without one, or at least trying to get something fun out of a paper without using a calculator, you're in the wrong subject. Sorry, that sounded harsh, but sure. Anyway, this question is about roots of a quadratic. When you have a quadratic that's got coefficients a, b, c, the sum of the roots is given by negative b over a, and the product is given by c over a. So these are just the formulas. You want to go into this exam knowing that. You can derive them. I think there's a video on this channel actually that derives those, but there'll be plenty of other better videos elsewhere. So just look for that. Anyway, these are the two things, which means that minus b over a is equal to minus 7 over 3, and c over a is equal to minus 2. I can cross multiply these out and get these two equations. Now, it's tempting to say, oh, well, how am I supposed to deal with this? Because you've got 2 equations and 3 unknowns. And maybe you know that you can't really solve when you have fewer equations than unknowns. What happens is there's an infinite number of solutions. But actually, that's fine. It says find a quadratic equation, not find the. It's just saying find one of them. There is an infinite number of ones that will do this. Just find one of them. So to do that, I'm just saying, well, what happens if a is 3? Because if a is 3, this makes 21, which makes b 7, So these are nice whole numbers, and if a is 3, of course, this is going to be a whole number as well, and therefore this is a quadratic that has the two answers. So when you get to this, just pick one of them being random, so something random, not completely random because you want integers. So I chose something that would make this work. But yeah, and then of course, where are all the other quadratics to do this? Well, just multiply by 2, or multiply by 3, or multiply by -7. That's where all the other ones come from. But anyway, this is what I would have written. Okay, show that alpha minus beta is 11 over 2. This is not worth 2 marks. This is worth like 4, because it's about the same amount of work as this is. This should have been 3 and 3, but whatever. What you need to do, people who have done lots of these papers will have seen this trick before. Consider alpha minus beta all squared is what you need to do. Now that squares out to make this, of course, just by expanding brackets. I don't know why I wrote that twice. I think I meant to swap the order of these two. But anyway, next you consider alpha plus beta as this, and you square both sides of this. So when I square both sides, negative square to positives, just square top and bottom, this squares out to that. And now what we can do is we can say, well, alpha beta is -2, so this whole thing here is -4. Add 4 to both sides and you get this. 4 is the same as 36 over 9, so I've just added 36 over 9 to this, which makes that. Though you've got a calculator, so you didn't need to know that. Anyway, here, that means alpha plus beta squared, alpha squared plus beta squared is 85 over 9, and alpha beta is +4, as we've already said. Put these two things together and you get this, which remember is alpha minus beta all squared. And now finally I can square root to get that. Maybe there's a quicker way of doing that. There's actually worth 2 marks. I couldn't find it though, so I'm a bit annoyed at myself. Anyway, last part, I've written down all the things I discovered in the previous question. Find this. Now you could consider the whole thing about roots that I considered earlier here. I thought I would do this the long way around and just derive it anyway. If a quadratic has these two roots, you can write it like this. Like if a quadratic has roots 5 and 2, it can be written x minus 5 into x minus 2. That's just how factor theorem and quadratics and polynomials of any degree work. Now if I expand this out, I get this. So it's x squared minus this minus that lots of x, which I can just say minus into a bracket here, and then this times this, 2 negatives make a positive. Now, when you simplify this, you realize that you know almost all these things. In fact, you already know alpha plus beta. That was in the question. Alpha minus beta you just found out. Alpha beta was in the question, so that can all go in there. When you try and combine these fractions, times this one by beta over beta, times this one by alpha over alpha, and then put them together. When you expand out this, you can type that into a calculator, by the way, to get this. When you expand out this, you realize this and this cancel, and so you just end up with on the top alpha squared plus beta squared, which is this. Again, we discovered that in the previous part. Alpha beta is this. So put those in. I times everything by 18 here as well, just to make sure this wasn't a fraction, because we're looking for integer coefficients. This, actually, the 9 times by the -2 to make 18, which cancels with that 18 on the bottom, and you just end up with plus 85. You should definitely, I think, end up with plus 85, unless I'm mistaken. Yeah, it seems to me like that should be a plus 85, so apologies for getting that wrong. Check the mark scheme in any case. I'm a bit annoyed about that. Why have I? Because that minus and that minus should definitely make a plus. Yeah, that's weird. Okay, question number 10. So I like these questions. I think people who are doing well at GCSE maths should be doing these because it is just using GCSE maths. I think there's a really hard question in here. Just an aside here, has a square base, which means this side is 8 and this side is 8. I see lots of people when they do questions like this underlining key information. I think because teachers of other subjects tell you to do that, you just kind of carry it over to maths. There's no real need to do that. Underlining this word here is not going to do anything. What I would do is every time I read something like this, I would immediately transfer the information I know about this onto the picture. So as soon as I read square base, I'll stop reading there and say, well, if it's square, then if that's 8, that's 8, that's 8, that's 8, and all these are the right angles, I can just draw right angles onto them. And then I don't need to underline this word, because I've used everything about it. So that's maybe how I would think about that, and I'll do that again later on in this question. The height, which is given over here, but I'll put it here because that's more helpful. They're asking me to work out the height. These kind of questions are all about identifying triangles that will be helpful. So this triangle here, with the diagonal 12 here and up here, seems the most helpful because I know I can work out this diagonal here. because the whole diagonal across the shape is 8 squared plus 8 squared square rooted. Now, if you don't know this trick, when you square root a number squared plus itself squared, it's just that number root 2. So root of 5 squared plus 5 squared is 5 root 2, 6 is 6 root 2, and so on. So that's quite a nice little trick, which will save some time. If that's 8 root 2, then this, of course, is 4 root 2, and then the height is going to be root of 12 squared minus 4 root 2 squared. Type that into a calculator if you want. It will save you doing all this work, but the answer is 4 root 7. Okay, find to one decimal place the sized angle between OA and ABCD. Now, this is a completely symmetrical shape. All the diagonals are the same, it's a square base, so the angle between OA and the surface on the bottom is the same as this angle here, just by symmetry. Of course, this angle here I can work out by just doing cos inverse of this over this, or tan inverse of that over that. Doesn't really matter. Sorry, that would be sine, wouldn't it? Tan would be this over this. We've worked out this, of course, it was in the previous part. Any of those will get you the same answer, and the answer is that. Good. Next part. Find the sized angle between OAB, which is this triangle here, tilting down into the picture, and the base. Now, again, this is a symmetrical picture, so I thought it would be easiest to deal with this face instead. Just the picture, I think, is most clear. So here's this face I'm going to deal with. If I go to the middle there, that's clearly a distance of 4. Because it's half, it goes to the midpoint of a square. Half of 8 is 4, so that's 4. This is 4 root 7, as we discovered in the first part. I'm looking for this angle, so it's going to be tan inverse of that over that. The 4's cancel, so it's tan inverse of what? It's root 7, which is that. Next part, and this is, I think, a really tough question. Let's first draw what we need to do. Show that PQ, sorry, P is the midpoint of O to A. Again, I'm not going to underline the word midpoint. I'm just going to go over here and say, cross out this 7, this distance is 6, and so is this one. That's all I need to know about the midpoint. So just immediately transfer the information onto the page. Q is the point on BC, so I'll draw it with ratio 3 to 1. So if this whole length is 8, 8 splits, that's 4 parts, so it's 2 per part. 3 parts, 1 part is 6 to 2. So transfer that on as well. Now, I can just eradicate things from the picture, which helps me to see what I'm doing. It's kind of harsh that in real life you can't really do that, but I'm going to do it just so we have a better idea. We're looking for the length P to Q. Now, this took me a while to think about how you're going to do this, and it's very easy to go off in wrong directions, getting things that aren't quite correct and not dealing with quite the right thing. But the way that I eventually figured it out, consider A to C. We already know that. One of the things that you always want to do is consider the things that you've already worked out, because they try to write questions such that the information that you've previously found is going to be helpful in some way. So A to C we already know is, I think it was 8 root 2, right? Now, if I go from P straight down to that diagonal there, this distance is 6 and the whole thing is 12, which means this triangle is as similar to the triangle that you would put in the entire shape here. It's just half the size, because its hypotenuse is 6 rather than 12. So this length is half of the height, which is, the height, remember, was 4 root 7, so this is 2 root 7. Now I could work out this thing here, but actually, like, imagine this whole diagonal. It's being split into 2 triangles straight down the middle from the top downwards. You can split it into 2 triangles. And then I've already said this is half of this left-hand triangle by similar shapes. And so this kind of length from here to here is 3/4 of the whole diagonal. Now, why am I talking about that? Because if you draw a line going across to this side of the shape, that means that this triangle here is 3/4 of the whole triangle on the base, because this length, remember, was 3/4 of the whole thing. Because again, you split this into 2, and then half of this again here, so that's a half plus a quarter is 3/4 of the whole thing. Now that's important because it tells me that this distance is 8, of course, because it's a square base pyramid, which makes this distance 6 all the way across to there. And it also, because this distance is 8, this distance is also 6, again, because this triangle is 3/4 of this one. So okay, that's really really important, because now if I draw a line going from P down to this point here, which I'll just call R, I can do a bit of Pythagoras on 2 root 7 and 6 to find that P to R is 8. So that distance there is 8. And now I've got this triangle to work with here, which I can use to work out P to Q. This distance here is 4. Now, maybe just think for a minute, while I think for a minute, about how to logically justify that. Of course, if this is 6, then this is 2, because the whole thing is 8, which makes this thing 4 here, if that's 2, 4, and 2. So this is 4. So 8 squared plus 4 squared is this squared, and so we get 4 root 5. I think that's a really tough question, and it took me a long time to sit there and think about that. But anyway, it ends with an easier question. And bear in mind, of course, whenever you see a question that says, show this is equal to that, and you can't, please don't give up on the next question, because the reason they're asking you to show that is because this gets used in the next thing, and you don't actually have to have done this to get this right. So please don't give up on questions, particularly when it gives you information like this. Just go on to the next one if you can't do it, and just do that anyway. Now again, rubbing out information here, I've got P to Q is 4 root 5. I want to know the angle P to Q to A. So let's draw the line to A in, and now I can see a triangle here with 2 sides known. So if I know if I could just find the third side, I could just do cosine rule. Now of course this is 6, as we've already said. So 6 squared plus 8 squared is 10 squared. It's just a 3, 4, 5 triangle scaled up. And now of course I've got a triangle here with 3 sides known, so I'll just do cosine rule to find P to Q to A. Rearrange it if you want to, type that all into a calculator in one go, and you get 36.4. Excellent, last question. F dashed of x is this, that's the derivative, so I immediately want to integrate that to find f of x. So I'll integrate it, raise the powers up, divide by the new number. You've got a plus c here, of course, because when you integrate there's a plus c. Looking at the picture here, I know that when x is minus 1, y is 0. So let's put that information in. Y is equal to f of x, of course, so put that in as 0 here. So 0 there, put x is minus 1 in. You eventually end up with c is 27. And now it's asking me to find a and b. So a and b are when f of x or y is 0. And now I know one solution to this equation. Usually solving cubits is quite hard. You could just try random stuff if you wanted. That's a legit strategy. But I know that when x is minus 1, that's the solution to this thing here. I could put it in if I wanted to make sure, but it is according to the question. So that means x plus 1 is a factor, which means this whole thing here factorizes to x plus 1 times something else. Now, what is that something else? Well, if I were to expand this out, I can very clearly see that alpha has to be 2 to make the x cubed work, and gamma has to be 27 to make that 27 work. So I can fill those in. How do I find the beta? And by the way, as I'm doing this, you're probably thinking, could you not just do polynomial division? I absolutely could. Of course I could. I don't want to because I hate it. So now how do we find beta? Well, again, think about, if you expand this out, you need to get this. So let's think about the x's. There are 12 of them here. How do we make x's by expanding this? Well, it's either x times 27, which will give you 27 x's, or 1 times beta, which will give you beta of them. So 27 plus beta is this 12 here. And so beta is minus 15, and so this is my full factorization. Sorry, not my full factorization. I need to factorize this thing, which if you stare hard enough gives you that. And so your solutions are at minus 1, 9 over 2, which is 4.5, and 3. Now b, we can see from the picture, is less than a, so b is the 3, and a is the 4.5. Good. Part B is using integration to find this area. Now the only thing that we need to be careful of here is do not integrate the whole curve, which is this, between 4.5, which is a, and 0. Because when you integrate, areas underneath the x-axis count as negative. So what I need to do is I need to integrate just between 0 and b, which is 3. I need to integrate that, so I'll do that. I'll integrate it, I'll put the numbers in. Of course, when you put in 0, everything just goes away. So this, I just put in 3 here into a calculator and got this. And then I need to do this one separately, which is between 4.5 and 3. Again, integrate in the normal way, and then put all the numbers in. You can also, you don't need to put the 3 in, you can just say minus 58.5, because that's, that's what happens when you put 3 into here, because you just did it. But anyway, you put 4.5 in, and then take away what happens when you put 3 in, and you get this. Now, again, that's a negative number because it's below the axis. So to find the total area, I just need to pretend that this gave me a positive number and then add this to that. So add this and that together, and I'll get this, and that's my final answer here. Anyway, so that's the entire paper. So really well done for sticking through that and listening, and thank you so much for watching.